Before I even start this video, I just want to make sure that people understand that any mathematics that you hope to learn from this video, it's not here, all right? It's the mathematics within this project is complete shit and utter garbage, and I don't understand 90% of it, all right? I'll be honest. But you could try and contribute on the GitHub repository. It's open source and all that. And if you just want the finished solution, it's free on GitHub. But my point is that if you want to contribute, feel free to do so. I hope you enjoyed the video, and I hope you don't learn too many mistakes from me, because that's the curse of free tutorials. They're shit and made by people that don't really understand code like me. So good luck.
So let's get started. To begin with, let's set up a clickable square where we want our reticle to rotate around and fire from. Next, make a new 2D sprite and attach a 2D collider. Then make an empty game object and call it reticle. I'm just going to name it reticle for simplicity, but you can name this whatever reticle you're trying to make. We'll get back to adding children and new game objects to this later on, but for now, let's make two scripts. One of which will handle the reticle and another script to handle the clicking of the square. Go ahead and drop the reticle script on the reticle game object and the clickable script on the square. Now let's go and do some programming, and we'll start off pretty simple. So in our clickable script, we're going to declare a variable and call it reticle manager. It's just a reference to the reticle object that we have selected. So on mouse down, we're going to go ahead and call the public function selected, pass in this game object. We haven't made these functions yet, but we're going to make them in just a minute. And then on the on mouse up event, we're going to just call deselect on the reticle manager. And that's pretty much it. We'll go over to the reticle script and then we'll get started there. So in our reticle script, I've gone ahead and made a public function called selected. We pass in a selected game object as a parameter. I'm just going to debug.log selected and deselected on each of the functions to begin with, just to see if they work. So if we go ahead and go into our Unity editor here on the square object, we'll just drag and drop the reticle game object. And then if we hit play and then spam the square for a bit, we'll see a bunch of debug.logs coming up in the console. So everything is working fine, pretty good. Let's move on to the next step. So now let's go ahead and build our reticle. I'm going to drag in a couple of art assets right here. I'm going to put them in a folder and just call it art. And then I'm going to drag out each of the individual items into the scene. I'm going to skip the little triangle thing because I don't really want that for this for this reticle. So I'm just going to drag them under the reticle and then reset their position to 0 on all of them. And then I'm just going to go ahead and place them where I want them to be in the final kind of like layout and order. I'm also going to make this a prefab so that we can reuse it and change it a lot easier in the future. So I'm going to go ahead and parent like the pointy art thingy under an empty game object because the orientation of the actual sprite was a bit weird. So we just had to kind of, fix that. Anyways, so first of all, well, I'm going to make a header. You don't have to. It's just I like keeping it a bit tiny in the inspector. But first of all, we're going to make a serialized private list of game objects. I'm just going to call them points because these are essentially all of the pieces of our reticle that we're going to build essentially. And then I'm going to make a private game object, which is the selected object, which just kind of tracks which object that we belong to, which we're going to use on the line. So first of all, in the selected function, we're going to go ahead and set the game object to true. So whenever we select the object, it then gets enabled. Next up, we're going to set the position of the reticle to the selected position because we want the reticle to be on top of the selected object. You don't have to, you can put it anywhere, but this is what I'm doing right now. And then we're going to take the parameter passed in through the selected function and set that to the selected object. Then we're going to make some local variables that tracks the mouse position, the raw mouse position. We're going to translate that to the world position. And then we're going to calculate the relative position compared to this object and the mouse position, which is just mouse world position minus this position. Then I'm going to make a loop that we're going to use later. I just wrote some comments. We're going to handle the rotation and the position of each of these points that belong to our reticle later on. Then down in the deselect function, we're just going to set selected object to null. And then we're also going to just, for now, disable the object when we deselect it. And then if we go into the Unity editor and then start play, we can now see that we can enable and disable the object by just clicking on it. So very simple, the basic is done. And then we have these local variables that we're going to use for the position and the rotation of each of the individual points later on. So
the first thing we're going to do is just make a new script. I'm just going to call this point because this is a script that's going to be attached to our essentially points, right? Our individual pieces of the reticle. And I'm just gonna have a simple bool there. You can expand this, essentially, is my idea behind it. The idea behind this is that you can just kind of put whatever you want here. I'm just gonna do a simple bool that checks if it's flipped. So that way we can attach the script to all of the reticle points and then essentially just toggle on and off the ones we want to be flipped. And the idea behind flipped is that flipped will be essentially on the opposite side. So not flipped will be the items that are essentially supposed to move towards our mouse position, but then flipped is in the opposite direction. Next up, let's handle the point. So in our selected function, I'm going to make I'm just going to call a new function. I'm going to call it handle point. I'm going to pass in a mouse position relative variable that we made earlier, a distance that we haven't made yet, the index, and a reference to the point, which we haven't really made yet. So I'm going to go ahead and make the variable distance, which is just going to track the distance between the reticle and the mouse world position. So it's just going to be the distance between those 2 points. Then I'm just going to define the point, which is the point that we're currently iterating through in the for loop. The handle point function is really simple. We're going to define our parameters that we're going to need for this function, which is the mouse position relative. We need a distance to calculate. We also need the index to know which point we're iterating through. And then we need the reference for the point. And then we're going to declare a new variable, which is just the direction. It's going to start as 0. And then based on if the point is flipped or not, I'm going to essentially set the direction to either -1 or 1. Now, what this essentially is going to do is that we're going to multiply a bunch of values later on with this direction, which is going to determine in what direction we're actually moving these points. So I'm going to declare a list of vector 3s, which is going to be our start positions. I'm essentially just going to track all of the positions of each of the points at the start of when they first get initialized. And then in a private awake function, we're going to essentially loop through all of the points. So all of the game objects in the list of points. I'm then going to take that position of each of the points. So I'm going to take the position of point in points. I'm going to add that to the point start position list. And then I'm going to make sure that is a local position as well, because we don't care about the global position in this scenario. And then down in the handle point function, and then I'm going to go ahead and declare a start position that we can work with based on the index that is passed in by handle point. Right, so this is the part that I mentioned that might potentially be incredibly wrong and completely pointless, but there's nothing to learn from this in terms of mathematics or anything. I've really tried my best to understand how I actually managed to get the field that I was going for, but in the end, it was just a bunch of trial and error in terms of, does this work? Does this make you feel better? What do I even call this? I am not a math guru, and I think if you expected that, you've come to the wrong place, because I just like programming and look, the point is that hopefully you learn something from this video and stuff, but hopefully it wasn't maths, okay? Because that's most likely wrong. But anyway, let's continue. I'm going to declare a couple of variables here that are going to define our animation speed. So essentially the select duration, the deselect duration, and our amplitude variable, and then I'm going to also define a animation curve at the very start that essentially is going to, this is what you're going to use to adjust the essentially bounciness and how far outside of its bounds it's going to move, which it gives the animation a lot more life than rather than being linear. But yeah, let's define the animation curve, the select anim time, the deselect anim time, and then under a new header of drag settings, we're going to declare a float of amplitude, which is going to be the strength and how far each of the individual points will move when they are being selected and deselected. And then we're going to define another variable called clamp, which is going to define how far, like the max distance we can move until we can't really move the points anymore. Right, so next up, let's do the complicated stuff that no one really understands, which I'm going to start by declaring a float of magnitude, where we're going to take the amplitude times distance and the result of that divided by the distance. Then we're going to essentially make a new variable called point identity, which is the start position of that point times the magnitude times, the result of that times direction, which will then flip it in either or direction. Then we're going to set a target position, which essentially is the position where we want to end up before we really lerp it anywhere. So this is the mouse position relative times the point identity, and then times in either or direction. Then we're going to declare a lerp time, which is the time it's going to take for it to get to where it wants to be. I'm going to use the select anim time divided by the point identity times time.delta time to make it consistent. Then we're going to define the lerp position, which essentially just takes in the local position of point. We take it and then we set the target position, and then we just plop lerp time in there, right? Next up, let's declare a new vector 3 of final position, which is just the final destination, which takes into account the lerped position and everything we need to have. We're going to clamp it by a magnitude of point identity divided by magnitude, the result of that plus the point distance divided by the clamp, which I don't know if it makes any fucking sense whatsoever, but it kind of works like what I would, want it to work. Anyways, let's declare a float of point distance. Let's declare a new variable of float point distance, which is the world position of point compared to the reticle position, which is the object we're currently on. And then we're going to use point distance in the final position formula, essentially. So we're going to take point distance divided by clamp. Just before point distance, I'm just going to set lerpos set to be equals to 0 because we don't really want to alter that in any dramatic way. That's going to make sure it just stays at 0. And then finally, let's just set the local position of point to the final position. So now on the reticle script, on the reticle object, we can pass in a curve, just plop in a bunch of numbers. That's all you really need to do, and you'll see the result of it. I actually forgot to, Right, so don't forget to attach your point script to each of the objects under your reticle, and then set the one you want to be on the very, very front to be flipped. Right, so go back into your reticle script. I completely forgot, but we need to actually call this function somewhere, which we haven't really done. So we're going to make a private void of update, and then I'm just going to do a simple check if selected object is not null. We're going to add a coroutine later on for the retraction, so we're going to loop the objects back to their original position. For the sake of that, we're going to stop all coroutines, if any are currently running, and then we're going to call selected and pass in the selected object. So now if you try and run it in Unity, it will look a lot more like what it's supposed to. The only thing we really haven't done is the rotation. So let's go ahead and do that right now. So I'm going to make a new function and I'm going to call it handle rotation. We're going to pass in a point. So in our handle rotation function, we're going to pass in a point, and then I'm going to make a variable of vector 2 which is called a dir for direction. We're going to set it to input mouse position minus camera.main world to screen point, and then we're going to input this.transform.position, which is the reticles transform position. And then I'm going to declare another float of angle, which is going to be equal to mathf a tan 2, which I don't really fucking know what it means, I'll be honest. We're going to set direction.y, direction.x, and then times that by the mathf radians to degrees, is what I'm assuming that stands for. Point of transform rotation then should be equals to the quaternion angle axis of angle and vector 3 forward. So I don't know what any of that means, but it works. And if you try it in the Unity engine again, it will, and if you go ahead and click play again, it will look something like this. Hopefully, I'm assuming. You can adjust the inspector numbers, values, the curve, whatever, up, minus, negative, whatever you want. It will change the behavior. Right. So next up, we're going to make a new private enumerator, which is I'm going to call lerp object. We're going to pass in a point, so a game object, a position, and then the time it's going to take. And then we're going to declare a couple of variables that is going to determine our function, which is a current position, which is going to take the local position of point. And we're going to declare a new float, call it elapsed, set it to 0. Then we need another float called distance, which is equals to the distance between the current position that we have, so the local position of point, and then position, which is the position that we pass in through the enumerator function. Then we need a ratio, set that to 0 to start with, and then we need a while loop. Now, so our condition for our while loop is going to be as long as ratio is less than 1. And we're going to set elapsed to be plus equals to time.fixed delta time. And then we're going to set our offset to the animation curve evaluate ratio. So we're going to take the value of the animation curve at the point in time of ratio. So ratio is going to go up. We're going to increment that slowly but surely, and then it's going to return us that value on the animation curve, wherever that is. Then we're going to declare a new offset, which is the offset minus the ratio. And then we're going to say new offset divided by stiffness. The code isn't right here now, but it will be. And then we're going to take the regular offset and set it to new offset plus ratio. So that will be for the next iteration. We're not going to use that anymore now. But then we're going to make a new variable called inverted offset, which is right. And next up, we're going to take the local position of point, and we're going to set it to a lerped position. So we're going to go from current position to the position that we pass in with the duration as ratio. And then we're going to multiply that with the inverted offset. So it goes in either direction, right? Same as we did earlier with the direction in handle point function. Yield return null is just going to wait until the end of the frame. Then we're going to set ratio to be elapsed divided by time. So for the one line that we didn't really write correctly for it to actually work, we need to introduce a new private float of stiffness, which is going to determine exactly how much bounciness we add to our return animation. And then for our fix, we just need to set a new offset to be equals to new offset, then divide by stiffness. So next up, right above the lerp object function, I'm going to introduce a new private int of count. This is going to keep track of which animations have finished and which haven't, and we just want to check if all of them have finished. So we're going to do after the while loop a count plus plus, which is going to add 1 to the integer of count, and then we're going to check if count is greater or equals to points.count. And then if so, we're going to call a function called fire projectile that we haven't made yet, but we're going to make just now. So next up, let's go ahead and make a new private list of game objects. I'm going to call them launch points. Is essentially where our projectile is going to fire from. I did it like this with this approach. I wanted more opportunities to maybe fire 5 or 6 projectiles from different points of the reticle. So for our fire projectile function, we're going to loop through all of the points in launch points, and then we're going to get the component of shoot projectile. This is a script we haven't made yet. We're just about to make it in just a second, but we're also going to call the function of fire projectile. And then after the for loop, we'll go ahead and set the reticle, aka this game object, to be false. Now, real quick, before we start making the shoot projectile script, we're going to go into our deselect function. We're going to remove the game object set active false, and we're going to introduce another for loop here that is going to loop through all of the points. And then we're going to start a coroutine for each of those points where we call lerp object, pass in points, or the current point in that iteration. And then we're going to pass vector.0 as the position, and then the deselect atom time as the duration. So that is pretty much it. Now, if we go back in the Unity editor and we go ahead and make a new script and call it shoot projectile, you can call it whatever you want. It's a terrible name that I've chosen, but it's fine. I'm going to go ahead and declare a game object as point, which we're going to pass in the inspector, and then a private flow of speed, which we're also going to pass in the inspector. But this is for each individual projectile. So you can have different projectiles with different speeds. That's up to you. But for our fire projectile function, we're going to make this one public, so that's accessible by other scripts and other game objects. And then we're going to make a game object, call it projectile. We're going to set this to instantiate point null. Null is just, it's not going to inherit any position from anything else. And then we're going to set projectile.transform.position to be this.transform.position, just to make sure that it's starting where it's supposed to. And then we're going to go ahead and get the component of rigid body 2D. We're going to add a relative force of minus this.transform.right times speed. So in the opposite direction of right, which would be left, I guess. So make sure you go ahead and add the launch projectile script onto the reticle. That would be the one that's just called game object for me under the reticle. Then I'm going to copy and paste that one, remove both scripts, and just add a rigid body, because that's just a sprite I want to use anyway. So I'm just going to do that. I went ahead and renamed it to like projectile, and then I'm going to make it into a prefab. And then I'm going to drag and drop the prefab that we just made of that projectile with only the rigid body attached. I'm going to move that into the shoot projectile script, and I'm going to set a speed for it as well. And then on the reticle game object, we now have this public list that we can access. We're going to drag and drop the topmost child under the reticle hierarchy, which is the pointy end at the reticle, which just, that's where I want to fire my projectile from. So that's where it goes. And you can add as many launch positions, essentially is what I'm calling them, as you want. So you could have 5, 15, 20 different projectiles firing all from the same reticle in theory. But anyway, like obviously the rotation of the projectile is completely wrong compared to where the mouse is positioned and where you actually are trying to fire. So let's go ahead and fix that real quick. We're going to go ahead and make a new script. I'm just going to call it rotation velocity because it's going to rotate the projectile based on its velocity. So this is going to be a really simple script. We're going to make a private vector3 of velocity and a private rigid body of RB. And then in our private void awake function, we're going to set RB to be get component rigid body 2D. And then in our update function, we're going to set float angle to be equals to math f tan 2 pass on RB velocity y, RB velocity x times math f rad 2 degrees. And then transform dot rotation should be then equals to quaternion angle axis with the angle and vector3 forward as parameters. Right, just as a quick note, if you didn't know where to actually put the shoot projectile script, it's on the launch projectile game object. So the point where you want to launch your object from. And that is pretty much it. That is everything that needs to be done to get this script working. Now you can adjust these values as much as you want and do a bunch of different variations of reticles if you want. You could have 2 pointy ends, you could make a two-legged snake, you could make a single-legged snake. I guess snakes don't really have legs anyway, but you could do a bunch of different stuff. You can set the clamps really high or really low, or you can make it really delayed and kind of just mess around with it. You can make the curves crazy. Like it's the possibilities are endless, and I hope you enjoyed this video. If you did learn anything, or at least maybe you just enjoyed me talking for like almost half an hour, then please check out my Patreon. I can't put any ads on these videos. Like I literally can't. I don't have enough watch time on any of my videos. So